Hello, ladies and gentlemen. Welcome back. Without wasting time, let's go straight into the second question, which is 1b. And what is the question asking for? It is about domain and range of function. So before we answer that, let's remind ourselves what the concepts domain and range is all about. So given a function f of x, the domain of f, which I will sometimes write as dom of f of x, is simply the set of the input values that can go into f of x. That is the layman way to describe what the domain is. Okay, so it is the set of input values for which the function is defined. So any input for which the function will not be defined will be thrown out of the domain, will be thrown out of the real number system. Because at this level of the course or whatever function we are dealing with real numbers. So if any input value will not work well with the function, we have to remove it from the real values, and what we have left will be the domain of the function. Okay, then the range of the function, in simple terms, which I can write sometimes as range of f of x, is the set or the collection of all the output values. So the set of all the possible output values of f. And a major strategy that is used to find the range of f of x is the property that the range of a function is the domain of its inverse. Well, I don't want to turn this into a lecture video on domain and range, because what we just need is to be able to solve the question that we have here. So I think I'll go straight into solving those questions, and at the end of the day, if questions arise from them, we can look at them. So in the first question here, we want to find the domain of f of x equal to x squared minus 1 over x to the power of 4 minus x squared. So this is a fraction, and we know that for a fraction to be undefined, it means that the denominator is equal to 0. So ordinarily the domain is supposed to be all real numbers, but we want to remove the abomination numbers, the numbers for which f of x will be undefined. And in this case, when we have a rational function as this, we target the denominator. So we need to remove the values that will make the denominator equal to 0 from the entire real numbers. So we need to get x raised to power 4 minus x squared. What values of x will make this equal to 0? Technically, what we are supposed to solve is this non-equation. X raised to power 4 minus x squared is not equal to 0. Those are the values of x for which we are defined. But to not to confuse people, let's just do x raised to power 4 minus x squared equals to 0. So how do we solve this? Don't be tempted to do x raised to power 4 equals to x squared divided both sides by x squared, and you say x squared equal to 1, x is equal to 1. There's a lot of errors in that thought process. So when you have equations like this, the first thing that should come to your mind is factorization. We can see that x squared is common here, So if we factor it out, we have x squared into bracket x squared minus 1 equal to 0. So, and that means either x squared is equal to 0 or x squared minus 1 is equal to 0. And if x squared is equal to 0, that means x is equal to 0 or x squared is equal to 1. We could have also factorized there, but let's just do it the easier way. So we have x is equals to plus or minus square root of 1, which means x is equals to plus or minus 1. So it means the odd numbers that we want to remove from the entire real lines. And when I say odd, I mean numbers that will give us problem with this function are 0, plus 1, and negative 1. So that means that the domain of the given f of x, in words, if we are to write it in words, is a set of all real numbers except these bad boys, 0, negative 1, and 1. Technically, we can write that as a set of x in real such that x is not equal in the set 0, negative 1, 1. Or we could just write the real numbers minus or remove 0, negative 1, 1. In interval notation, that is the same thing as negative infinity, comma negative 1, union negative 1, comma 0, union 0, comma 1, union 1, comma infinity. Because the 3 points divide the entire real line into 4 segments. So if I have negative infinity and infinity, so negative 1 here, 1 here, 0 here, 1 here, they have divided the real line into this segment, this one, and I'm out of colors, so let's use red, this one. So, and those are the 4 segments that we have here. These, and this. So that's the domain. What about the range? So this one is a little bit technical, but we can find a way around it. So first and foremost, when a function can be simplified, we take that easy route, okay? Because a function and its simplified version, they look very alike, except for some holes and maybe some jumps, but they will have similar domain and range. So I'm using similar and not equal, okay? So we have to be very careful. So in this case, f of x is given as x squared minus 1 over x raised to power 4 minus x squared. This can actually be simplified because the denominator is x squared minus 1. So if we have this, the x squared minus 1 can cancel out, and we are left with 1 over x squared. So let's call this new simplified version g of x. So if we can get the range of g of x, that gives us an idea of the range of f of x. It's just that the range of g of x, which is a smaller version of f of x, is going to be bigger than the range of f of x. When I say bigger, I mean it contains the output of some of the problematic numbers that we have cancelled. So if we can get the range of g of x, and range is the set of the outcomes. If we can get the range of g of x, we just need to remove the outcomes of the input values that has been cancelled by simplification. I hope that makes sense. So how do we get the range of g of x? So what is the range of g of x? So what's the range of g of x, which is 1 over x squared. So if you are conversant with the graph of 1 over x squared, this is how it looks. This is 1 over x squared. That is to tell us that the output is the positive part of the plane. So it is from 0 to infinity. So the range of this is from 0 to infinity, every non-negative number. So, and it is easy to think of because x squared is usually going to be positive. And when you do 1 over x squared, you're also going to get a positive number. And we cannot get 0 as well. But if we want to use the fact that I have stated here, so g of x equals to 1 over x squared does not really have an inverse. But we can actually rewrite y equals to 1 over x squared and make x subject of the formula. This is a common trick that we use in getting the range of a function. So we make x subject of the formula. We cannot get an inverse here because we are going to get x equals to plus or minus square root of 1 over square root of y. If we make x subject of the formula, and anytime we have plus or minus there, we know it's not a function. But we can think about this. So what's the domain of this function? This function is a fraction. The denominator cannot be 0. But also the denominator has a square root. When we have a square root, we know that the only type of numbers that we can put in are the positive numbers, non-negative numbers, 0 and above. Okay, but because it is also a fraction, 0 cannot go in here. So y must definitely be greater than 0. That is the domain of this function. So the domain of this function here, when we make x out of the formula, is a range of g of x, where g of x is 1 over x squared. Now, this is the domain of this is the range of the simplified function, simplified version of f of x. It also contains the output of 1 and negative 1 that must not be in f of x. We said domain of f of x, all real numbers except 0, negative 1, and 1. But the domain of f of x is just all real numbers except 0. The g of x recognizes negative 1 and 1 in its domain. So this range is going to include those outcomes for negative 1 and 1. So it means that the range of f of x is going to be the range of g of x minus, we have to remove g of negative 1 and g of 1. But what is g of negative 1 and g of 1? So g of negative 1 is equal to 1 over negative 1 squared, which is equal to 1. And that is the same thing as g of 1. So it means the range of f of x is 0, infinity, and we are removing 1. But what is that? That is the same thing as 0, 1 union 1, infinity. So we are looking at from 0 to infinity, and we are plugging 1 out of it. We are busting that line. So we'll be left with from 0 to 1 and from 1 to infinity. So this is the range of f of x. And I think that is a good place to stop this video. When we come back, we'll come and look at the second part, which is the domain and range of 1 over square root of x minus 3.